Now we begin to focus on the angle measures in polygons. Let's begin with what a diagonal means, because we're going to use that to help us tell about angle measures. A diagonal is a segment joining two non-consecutive vertices of a polygon. What does non-consecutive mean? Well, consecutive means one right after the other, next to each other. Therefore, non-consecutive means not next to each other. So I want us to draw the diagonals of each polygon below from one vertex only. So we're going to draw a diagonal from one vertex only. Here is a vertex. Consecutive to this vertex would be this one. If I traced to this vertex, I would be tracing a side, not a diagonal. Here is a vertex not next to this other vertex. Therefore, if I trace from this vertex to this vertex, I am creating a diagonal because I am not going to the consecutive vertex, I'm going to the non-consecutive vertex. Now that's the only one that I can draw in this four-sided polygon, this quadrilateral, and that's all that I was asked to do from one vertex only. Then we determine the number of triangles created in each polygon. I see a triangle here, that's one. I see a triangle here, that's two. So this picture has two triangles. In this polygon, I will pick one vertex. I do not trace to here because that's a consecutive vertex. A diagonal goes to a non-consecutive vertex. Here's another non-consecutive vertex. Those are the only diagonals I can draw. I've created 1, 2, 3 triangles. Why am I asking how many triangles? Because we know more at this point about triangles than we do about other polygons. Let's go ahead and look at the next polygon. Pick a vertex. Trace a diagonal. I can trace a second diagonal. I can trace a third diagonal. How many triangles can I make here? 1, 2, 3, 4 triangles. And finally, the last example, pick a vertex, draw a diagonal, 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 diagonal. This time I can create 1, 2, 3, 4, 5 triangles. Now our goal in this part of the lesson is to talk about the measures of the interior angles. We know about how many degrees a triangle's interior angles has, right? Every triangle, one triangle, its interior angles add up to 180 degrees. Let's go ahead and look at the table. We're going to come back to this picture, but I'm expecting that you will know by name each type of polygon according to the numbers of sides that it has. That's called classifying a polygon. To classify a polygon means to put it in a group, to name it, in this case, by the number of sides that it contains. For example, 3 sides, we know that type of polygon is called a triangle. Please list the others and memorize those names. You will be expected to know them and know how to spell them. 4 sides is a quadrilateral. 4 for quad, lateral sides, quadrilateral. 5 sides, think of downtown, there's a building that's shaped like this, the pentagon. 6 sides is a hexagon. 7 sides is heptagon. 8 sides is octagon. Notice all of these are agon, 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 agon. Please know that and spell it correctly. 9 sides is a nonagon. 10, decagon. Think of a decade as 10 years. Decagon is a 10-sided polygon. 11 sides can either be a hendecagon or undecagon. 12 sides is a dough for 2, decagon. So 2 sides added to a decagon, kind of like how 11 is hen decagon. Hen is a prefix for 1. Un is a prefix for 1. Anything bigger than 12, we really just name it by the number dash gon. So I'm going to say n for any number and then dash gon. That's how we name it for anything above 12. Now let's talk about the number of triangles, because that's going to help us know how to find the sum of the measures of the interior angles. A triangle, that's one triangle, its angles add up to 180 degrees. We know that. We've been spending a lot of time on triangles. And that's why I asked to split up on the previous slide these polygons into triangles. And just triangles, not as many as we can, but triangles whose interior angles, like this angle, and this angle, all still touch the sides and the vertices of the polygons. Then there's another triangle here, 1, 2, 3 angles. Well, how many degrees do these 3 angles add up to? 180 degrees. How many angles do these 3 angles add up to? 180 degrees. Why? Because they're triangles. All triangles' interior angles add up to 180 degrees. Well, if we have 2 of them, that will be 2 triangles, 180 degrees each. That makes 360 degrees. If we have 3 triangles, well, that's 3 triangles times 180 degrees each, 180 degrees in here, and in here. Therefore, altogether, 540 degrees is the sum of the measures of the interior angles, and so on and so forth. So knowing how many triangles we can split it up to by the diagonals helps us to tell the sum of the measures of the interior angles of the polygon. Quadrilateral. As you saw in the picture above, we created 2 triangles. Well, 2 times 180 made 360 degrees. Pentagon, 5 sides, 3 triangles. 3 times 180 made 540 degrees. Hexagon, 6 sides. Look at the picture above. How many triangles? 4 triangles that we made. 4 times 180, 720 degrees. Can you think of a rule for going from the number of sides to how many triangles that it makes? Let's look at what happens in each one. 3 sides to 1 triangle. 4 sides makes 2 triangles. 5 sides makes 3 triangles. What's the connection between this number of sides and this number of triangles? Do you see it? There you go. Subtract 2 each time. Number of sides, subtract 2. Number of sides, subtract 2. 7 sides, subtract 2. How many triangles do we get? 5 triangles. Therefore, 5 triangles at 180 degrees each makes 900 degrees. 8 sides, subtract 2. 6 triangles at 180 degrees each. That makes 1080 degrees total. And so on and so forth, we can continue with the table. If we get down to n sides, can you think of a rule for that? Why don't you pause the video, fill in the rest of the table, and see if you can think of a rule for n sides. Did you come up with a rule? Number of sides. To get to the number of triangles, we take that number, we subtract 2. Therefore, we take that number, we subtract 2, and then we multiply it by 180 degrees because that's how many triangles we have. So now we get to our rule of the polygon interior angle theorem. First, let's make sure we all understand that the term n-gon is a generic way of classifying n-sided polygons. A polygon with 14 sides is a 14-gon. That's just when we don't have a name for it, we're going to call it that. The polygon interior angle theorem, very useful for a lot of things that we need to do, especially finding angles in polygons and using that information. This theorem says that the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180. Memorize this. We're going to use this a lot. Let's apply it to these examples. Use the polygon interior angle theorem to solve for x. Why are we using the polygon interior angle theorem? Interior angles is what we have in this picture of a convex polygon. First, we have to figure out how many degrees all these angles are supposed to add up to. Now we did make a chart, but let's pretend we don't have the chart in front of us. This is the way we figure it out. N is the number of sides. N equals, well, I could count the sides, but the number of sides is the same as the number of angles, and sometimes it's easier to count the angles because I can put a dot at each angle as I count at each vertex. So 1, 2, 3, 4, 5. N equals 5. So I'm going to do 5 minus 2 times 180, or 3 times 180, and that makes 540. So I know that these angles all have to add up to 540. 540 is the sum. So I'm going to add them up. 2x, 5x, 5x. Add those up. Also, 90 and 90. Let's put that in a different column so we don't get confused. Adding up the constants, 180. Adding up the x's, 5, 10, 12. 12x plus 180 equals 540. Does this look familiar? We used to do this with triangles. Let's solve for x, subtracting because we need to subtract. 12x equals 360, dividing by 12, x is 30. Would you like to pause the video and try the next one on your own? So if you'd like to work with me here, let's start by counting the angles. 1, 2, 3, 4. 4 angles means 4 sides. So n equals 4, and our formula is 4 minus 2 times 180. 2 times 180 makes 360. So 360 is the sum. All these angles add up to 360. Let's line them up. X plus 4, 2x plus 1, 3x minus 2, and x. All the x's, 7x plus 3 equals our sum, 360. Now we're going to solve. Did you also get 51? Great. Let's look at another way we could be using the polygon interior angle theorem. The sum of the measures of the interior angles of a convex polygon is given. Classify the polygon by the number of sides. Notice the words that I've highlighted here. We're given the sum. The sum that we're given in number 3 is 1,440 degrees. We have to work backwards this time. We don't know how many sides there are. The number of sides, n equals, I don't know. Well, remember our polygon interior angle theorem. The sum equals n minus 2 times 180. What part of this was given to us? Not the n, we need to find that. We are given the sum. So we're going to take what the sum is and we're going to put it in there. 1,440 in this case. Let's go ahead and write that equation. 1,440 equals n minus 2 times 180. We have to solve for n. Think about how we can undo this. This is multiplied to 180, so we're going to divide by 180. So we get 8 equals n minus 2. How do we make the minus 2 go away? Plus 2. So ultimately we have 10 equals n. The number of sides is 10. Now, this is basically just using the formula backwards. So think about how we can just use the formula backwards. think of what it's like forwards and go backwards. We're subtracting 2 first, then we're multiplying by 180. So do those two things in the exact reverse order. We take the number they gave us, 1,440. Instead of multiplying by 180, we divide by 180. Instead of subtracting 2, we add 2. Just use the formula backwards. That's basically what we did here. Divide by 180, then we added 2. That still gives us 10, and therefore we know we have a decagon. And if we can name it, that's how we give our answer. A 10-sided polygon or a decagon. Let's look at number 4. Maybe you can pause the video and try it on your own. Hopefully, you're thinking, I like the way we did it, where we just thought of the formula backwards. So if the formula is minus 2 times 180, here's the formula backwards. Divide by 180, add 2. What did that make? 14. So what do we have? A 14-gon.